Calculus BC, lesson 7.3, Antidifferentiation by parts. So, we've been doing substitution, and it's nice, but the problem is, how do you integrate something like this? You don't have a cosine of x squared, where you take the derivative of that, and you get 2x, and you say, oh, chain rule will help me out. You don't have that. So we introduced something called integration by parts. First thing we're going to do is take the derivative of uv. Notice all my v's have a little tail. Several people have pointed out that's not the right way. Tough. And this equals u dv dx plus v du dx. Well, then we do something weird. We integrate both sides with respect to x. And we get uv equals integral of d dx. Trying to make sure I'm doing this right. Oh no, I've already reorganized it. Integral of u dv dx plus the integral of v du dx. Well, if we let our dx's cancel and then reorganize so that we get, and we kind of just picked one, integral of u dv alone, we get this. And how's it work? U equals x, dv equals cosine of x, dx, du equals dx, v equals sine of x. Notice we're integrating and we're derivating and then integrating. So we're going to get this one first, x sine of x minus the integral of these two. A lot of people say, well, I don't know how that happened. I said, well, that's what this formula up here says. And it's just another way to do this without the ability to do substitution. We can integrate sine of x. It's negative cosine x, so they'll cancel. We get x sine of x plus cosine of x, and then we always put a plus c for an indefinite integral. So that's complicated, but what I've written down here, the goal here is to just go from an integral that we can't do to one we can. So for example, we can't do, there's no substitution here. So we do the same thing we just did. U equals x squared, du equals 2x, dv equals e to the x dx, v equals e to the x. We get x squared e to the x minus integral 2x e to the x, I've got my dx here, dx. I'm going to pull my negative in just because I think I'll screw it up otherwise, because now we get to do the whole thing again. Negative 2x du equals negative 2 dx. And notice the whole reason we're doing it again is that we could not still do substitution. So here we have e to the x dx and v equals e to the x. So we get the original issue. Minus negative 2 e to the x dx, cancel, and we can take the integral of that last one. Do not simplify. We're perfectly happy with leaving it in that state. I have seen textbooks simplify it and try and do this and that. You don't have to. Here we have an initial condition. So we're basically doing the same thing. Y equals the integral of x ln of x dx. I want to make sure I do my substitution right. So a lot of people like to rewrite it. I'm just going to go with u equals ln of x, du equals 1 over x, dv equals x dx, v equals x squared. Which point you say, I thought we were supposed to be getting rid of that x. Now you're adding it back. To which I say, trust me. X squared ln of x minus the integral of x. Why do I keep forgetting my dx over here? X dx equals x squared ln of x minus x squared over 2 plus c. Looks like I made a mistake in here somewhere. I gotta go find it. Over 2. Naughty, 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 naughty. Over 2, over 2, over 4, over 2. My bad. Sub in y equals negative 1 to find our c value. Negative 1 equals, when x equals 1, 1 times ln of 1, which is 0, minus 1 squared over 4 plus c. So if we look at that, we're going to add 1/4 to both sides. We're going to get c equals negative 3/4. So there it is with a initial condition, just that extra step of finding out what the c value is. So now we look at the tricks. And if you notice anything about the integrals we've taken so far, we always said dv equals the trig or the e to the x, but we also said u equals the ln of x. Watch out for those. That's just something you want to be paying attention to. Another one that never actually works, and I just have to break my rules right now. Well, wait a minute. Which one is it? Well, if they're together, then you say u equals the e to the x. So we get integral of e to the x cosine of x dx equals e to the x sine of x minus integral e to the x sine of x dx. You say, oh, that didn't really help. We have to do it all again. To which I say, yes, you do. U equals e to the x du equals e to the x dx dv equals sine of x dx v equals negative cosine of x. Integral of e to the x cosine of x dx equals e to the x sine of x. I usually throw my minus in because this is where things get messy. Plus, because they're going minus, and we're doing this one, and that's a minus minus. E to the x cosine of x minus minus plus integral of e to the x cosine of x dx. Notice we have one here and one here. we are going to add to both sides. Which means we'll have two of these. Integral of e to the x cosine of x dx equals e to the x sine of x plus e to the x cosine of x divided by 2. And we get equals e to the x sine of x plus e to the x cosine of x all over 2 plus c. Again, some people like to put the plus c in earlier. Really doesn't matter. It's all going to work out. But it's pain. It's a significant hassle. So here's integrals of the form blah, 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 where f can be differentiated repeatedly to become 0 and g can be integrated repeatedly without difficulty. They're good candidates for integration by parts. Sometimes it's really easier to do this with a table. So I'll show you how to do this one. Let me see how much more I got to go. I think we're going to have to stop here. I'll pick this up on my next video. That's it. As always, happy mathing.